Uh, Again, welcome to another video lecture of control system series. So this is the topic which we are going to discuss in this video is block diagram reduction techniques. So the topics which are to be covered in this one is what exactly the block diagrams and how we can able to reduce based upon the series connections or parallel connections and or both and are also having different way of blocks are there. So how we can able to reduce based upon what we are going to discuss in this total video. So first of all, what is the representation of the blocks? Means it is a simple representation, but in a technicality, in our any of the circuit diagram, we are having multiple number of inputs or multiple number of outputs, which are having some can be controlled, some can't be controlled. So everything can be represented in one block. So that each block will be represents related to the one transfer function can able to done. Like for example, if one capacitor is there, that can be represented as one block diagram. If one converter is there, that can be represented as one block diagram. One motor is there, that can be represented as one block diagram. Input can be represented as one block diagram. That not block diagram as a block, so that everything can be reduced. If the system is very complex, we can't able to make a one system which is having a very short way. So regarding that thing itself, many blocks can be reduced by using this block reduction techniques, and also we can make a simple block diagram. And why reduce block diagrams? That is the reason what we call it as we are having many interconnected systems. For example, in the before lecture itself, we have discussed about the transfer function of AC servo motor, in which we are having many components. Like for example, inertia is there. For example, voltage is there, current is there, resistance is there, inductance is there, angular position is there, position to voltage is there, torque is there. Many things are being controlled. So these are all things will be come under come in when we are representing in a block diagram. But when it comes to the block diagram, to get a if you want to get a block diagram, sorry, transfer function from one block diagram, it will be very difficult. So that's why what we are going to do is we are going to reduce that one to make the understanding very easily. Now, what are the common elements in the block diagrams? We are having a common configurations based upon that one. One is the series blocks will be there, parallel blocks will be there, and also the another thing is the feedback blocks loops will be there. This is a simple example. It is not related to the block diagram, but I'm just giving like the series and parallel circuits. Here, if you see, the battery can be represented as one block, and also the two bulbs can be represented as two blocks also. So that is simply we can able to introduce that one also. Simple understanding purpose, I am just giving for a series and parallel connection. And the next one is, for example, here there are multiple rules will be there to represent to reduce the block diagrams. So the rule one is which is related to the series blocks. Okay. So whenever the two series blocks are there, then automatically that need to be multiplied. For example, G1 is one block and G2 is another block. We want to represent in one block, so we can represent like it as a G1 into G2. Then automatically what we will get is we will get a one series block which is having the same parameters, which really comes to the one block itself. In the same way, the next rule will be related to the parallel block. So when it comes to the parallel blocks, automatically what we need to do is we need to add or subtract. Add or subtract, why? Because parallel blocks, it is depends upon the what are the signs it is having. So that's why we are having a add or subtraction will be there based upon the signs. Okay. For example, G1 plus G2 can come, or G1 minus G2 can come, or G2 minus G1 can come. So anything can be possible. And the next thing is related to the feedback blocks. So feedback blocks, whenever feedback blocks will be there, it will be represented with respect to the, for example, one feedback block is there, that is H of S. So it is simply we can able to represent by the G of S by 1 plus G of S into H of S. Simply we can able to represent in this one. How it is done can come. It is a simple multiplication and division. So it is easily can able to done. So there is another point of another important thing is there to reduce the block diagram reduction technique, that is called it as a one of the summing points will be there. Summing point is, for example, two blocks are going to join with respect to the plus or minus, or they are calculating the error, that means then automatically we need to use that also into consideration. But when it comes to the block diagram reduction, we can able to shift the summing point to either to the front side or to the back side also it can able to done. So this is also can able to done. So that is what to reduce the complexity, so that things can able to done, but it doesn't get that much of big changes in that one. It make the reduction easier. Okay. And the next thing is about, for example, let's take it as a one example, that is called a basic block diagram representation. For example, if I'm taking a block diagram of which is having a input of A, and also feedback loop of B and an output. That's it. There is nothing will be there. So that means if, for example, this is the thing. So this how I can able to represent means if I have the B as a feedback loop and A as the only the one block is there. So then automatically I'm going to represent this. Then automatically the block diagram representation of the transfer function will be related to the A by 1 plus AB, as we already discussed in the previous just before itself, how it will represent when it comes to the feedback. In the same way, if we are having a complex diagram, okay, let's take it as a one complex diagram. If you see here, there are multiple summing points are there. In the first summing point is there, which doesn't have any feedback loop, and next summing point is there, which having the H1 block is there, and also another summing point is there, which is having a H2 block is there. So in these three type of things, if you want to reduce means here there is no series connections are there, no parallel connections are there. But we can, if we shift this whatever the H2 block, whatever wherever it is getting, so if we shift that to the back side, then automatically what will happen, G1 G2 will be comes into the series, then it can be reduced to the 1. Then after that again the same, after whatever the things it will come, it will be in series with the H1, then it will be reduced. Then after that we can shift the point whatever this G3 to before point is, that also can able to shift, or we can able to make the things into one line which is having a connection of the series, and after that it will be going to the parallel to the H2. So by this way it can easily can done. So this one you can easily try to do this one, and if you have any doubts you can just ping us. And the next thing is how we can able to do it. There are different type of precautions are there to do the block diagram reduction techniques. That is, first one is, first you need to combine the series, then after that you need to go to the parallel. Not like it is the first you need to go to the parallel, then you need to go to the series, because first it comes to the series like it has the same loop is going on, and after that only it will comes to the parallel where it will be divides, and after that whenever the feedback loop is there, then automatically it need to be considered. So then finally one single block representation can able to done, which can be represented as a one transfer function. This can be able to done. And the next thing is complex block diagram representation. There are many things are there, like when you are working on a complex block diagram, first you need to check with that what are the inner feedback loops, and after that series parallel moving the points, these things can be done in a step-by-step manner. If you are doing from a front side or from like input side to output side, or output side to input side, or anything also, by this way you can able to reduce the block diagram very easily. And then it is there are multiple common mistakes out there which can able to do by many people when we are doing the block diagram reduction. That is wherever you are moving the the summing point to the front side to back side, or back side to front side, then automatically, or whenever you are doing the reduction of the thing, the plus and negative signs will be mostly, it will be confusing. So you need to very careful about that one, because when if you are do any plus and minus to minus and plus also, the complete transfer function will be collapsed, and also we can't able to control also. And also Laplace domain rules also some people will not apply easily, so that thing also we need to see. So, and the applications where we can use this application, that is also you need to understand. So that is, one is PID controller design. That means whenever we are going to control one anything, so the PID or PI or PE controller based things only most people will do, or PRP, anything. So multiple control designs are, so there we can able to use this one. And also next, stability analysis, and then it's simulating modeling, real-time embedded system control also we can able to use. So in this many places we are able to use this block diagram reduction technique to find out the transfer function, also to find out one complexity big block diagram to the simple block diagram itself. So it will help you to understand like it as a initial understanding of the what is the total system it is working on, what are all the parameters it is considered, what are all the parameters it is going to find out, and anything. Okay.